Hello. For these three problems, you want to use Excel. And it says the amount of time people spend at Grover Hot Springs has a mean of 74 and a standard deviation of 14. And so here, the distribution, you just use the mean and the standard deviation. There we go. Find the probability that a randomly selected person stays longer than 65 minutes. So equals norm, and you want the normal distribution, the second one, and then we put our x value, which is 65, comma, your mean, standard deviation, and then you place a 1 because the total under the curve is 1. Now what this is giving you is the percent below. We want the percent above. So we go equals 1 minus and pick that value and hit enter. There we go, so it'll stay up there. The next one says the Park Service is considering offering a discount of 4% for patrons who spend at least the least amount of time at the hot spring. What's the longest amount a person can spend? So on this one, they're giving us the probability. We do equals norm, but we use the inverse one because we're given the probability. And the probability was 4%, written as a decimal, 0.04, comma, your mean, which was 74, and the standard deviation of 14, and you hit enter, and there's your answer, 49.4903. The last one, when you're working with quartiles break things up into quarters or 25%. So Q1 is right here, and that means 25% is below it. So when you're finding it, it's equals norm, and then you use the inverse one because we have the probability, and 25% is below it with your mean and your standard deviation. It's the 64. And then this is the median, 50% below, and we wanted Q3, that's right here. Notice that 3/4 or 75% is below this value. So to find it, then we go equals norm. Again, we have the probability, so we use the second one, 0.75, and then the mean and the standard deviation, and there's that value. To find the inner quartile range, you just subtract those. This problem here, very similar. This again is your mean, which in this problem is 2942, and the standard deviation 510. Find the probability a customer consumes less than 2680. And when you do the norm, that's what that gives you. So here equals norm. You want the probability, so we use this one, 2680, comma, the mean, 2942, comma, 510, and our total is 1 under the curve, and hit enter. So this is the percent below, and they said to find the probability that it consumes less, so that would be the correct answer. If they wanted greater than, you'd have to subtract from 1. What proportion of customers consume over 3111? So this one you'd have to subtract. Now, if you want, when you're typing all these, you can go into it again, and then we can just change going over here. We can change that number to 3111 and hit enter, and it will change it. Now, this would be the percent below. We want it above, so then we can go equals 1 minus and click on this value, and it will subtract them for you. 3702. The Piggy Award is given out to 1% of the customers who consume the most calories. What is the fewest number of calories a person must consume to receive a Piggy Award? So the Piggy Award will be given out to 1% of the customers who consume the most calories. Okay, so if we go equals norm, and we're given the percent, so we use the inverse, and we go 0.01, comma, the mean 2942, comma 1. This is going to give us below 1% of the customers who consume the most calories. Okay, so since this is giving us below and we want above, we need to subtract 0.01, so it'll be 0.99. Because 0.99% is below if 1% is above. Oops, what did we don't need the 1 on that one. Because we're given the percent, you only need probability, mean, and standard deviation. There you go. So in this one, I used the 0.99 because it said 1% is above. So remember, this uses below, so we need to know what's below. If 1% is above, 99% is below. So that's why we had to use 99. One more. On the planet Mercury, 4-year-olds average 3.2 hours a day of unsupervision, with a standard deviation of 1.7. So this is our mean and our standard deviation. Find the probability a child spends less than 2.3 hours unsupervised. Less than, that's what our probability gives us. And so equals norm. We want distribution. And then we put 2.3. Standard deviation, or mean and standard deviation, 1.7. And it tells you what to put. So we put X, we put the mean, we put the standard deviation. Cumulative is 1. And there's our value. What percent of children spend over 3.5 hours? So equals norm. Again, we're looking for the probability. 3.5. The mean, 3.2. Standard deviation, 1.7, comma 1 for the total under the curve. Now this is giving us below. We want above, so then we have to take equals 1 minus and click on the 1 above it. Oh, and this one wanted it written as a percent, so then you just multiply this by 100, and you'll get 43%. 82% of children spend at least how many hours a day unsupervised? At least. So that means that value or more, because 82% of all children spend at least how many hours unsupervised? So equals norm inverse. Now the probability supervised. So this one is 82% spent at least how many hours? So that would be how many hours at least? More. So 82% is above, which means that 18% is below. So you have to be careful of the wording. We want to use 18 with our mean 3.2 and our standard deviation 1.7. There you go. So the reason I subtracted it, the 82% from 100 and got the 18%, is because it said at least how many hours. So 82% should be above what value, and we needed the percent below.